Hello there, and welcome to a casual educational deep dive on my part. Today, I'm hoping to essentially go over some performance profiling and essentially learn how to do it and then apply that knowledge to quantifying the performance differences between, most importantly, OCaml versus Golang, but also Rust versus JavaScript. Frankly, Rust and JavaScript are extremely useful languages, but they both kind of vary in terms of in terms of how interesting I find them. So obviously, JavaScript is just extremely popular because it utilizes some very easy to understand paradigms, and it's extremely easy to get up and running with JavaScript. It has such a low barrier of entry that it's one of, if not the most popular programming language on the planet. Rust, on the other hand, is an excellent systems programming language. Obviously, though, there's been a lot of drama in the sort of Rust community lately with the Rust Foundation, and so that drives a little bit of hesitancy towards learning it. I haven't personally learned it. I would love to at some point, but I haven't yet. So, with regards to Rust, it's not something that I use particularly often, and so that's why Rust and JavaScript aren't as interesting to me as the OCaml and Golang languages in terms of comparing performance. As much as that is the case, it is still important to me to include them because if performance is important to you, then Golang versus Rust versus JavaScript is going to be an important conversation in multiple instances, such as this video by the Primogen, where he goes through Go and Rust and TypeScript, which is JavaScript, essentially comparing them and their performance. And so my hope is to kind of make something similar to this. Eventually, I want to make a more comprehensive and condensed video, but for now, I need to actually learn how to do this, which is why in here I'm going to start kind of documenting my learning and essentially make a video about that. That's the goal. So, with regards to why OCaml and Golang are more interesting to me, Golang is an excellent language, and OCaml is an excellent language. They follow extremely different paradigms. So, OCaml follows a functional programming paradigm, and Golang is more imperative and supports other paradigms as well. So essentially, OCaml is primarily functional, but it also does support OO and imperative paradigms technically, whereas Golang is primarily imperative and supports other paradigms as well. So these are extremely powerful languages, and I don't want to pretend that their domains overlap too much. They definitely have specific use cases that sort of make it so that the performance of each individual language should not impact necessarily your use of them. And it's also worth considering that OCaml is a very different community as well, and has a lot of different use cases. I mean, I said that they had different use cases, but it's worth noting that OCaml and Golang have very different sort of problem sets. Golang is primarily used for server-side request handling. It's extremely performant, and it's built with one of the best concurrency models that you can get, and it was designed custom for Google by some of the smartest minds there to handle Google level server-side and cloud-based problems. Whereas OCaml is rarely used in the industry, although it has been used a bit by Meta and primarily Jane Street. Jane Street's the biggest sort of player in the OCaml space, but things like Reason ML, which, as far as I know, was designed by and implemented by Meta, are also supported and are kind of built off of Golang and are kind of built off of OCaml. So it's important to note that these two are very different languages, but they are worth comparing because, for me, they're both extremely interesting languages, and they do overlap enough to where I would like to, learn both of them, and I plan to, but while I am learning both of them, it's important to me to sort of prioritize in certain situations. Is it better that I build a thing in Golang, or is it better that I build it in OCaml? Now, I want to get into sort of how I'm going to approach learning this and how I'm going to actually compare all of these things. So performance profiling has a couple of different sub-questions to it that I would like to answer primarily today. The first one is, what is performance profiling? The second one is, why does it matter? And the third one is, how do you measure performance? So with regards to the first one and the rest of these as well, I'm basically just going to go through a bunch of different reading material and education material and stuff like that, and try to sort of learn more about this. One of the primary ways that I do kind of plan on doing that, not particularly for this video, but just generally, is to watch the Primeagen series. Obviously, you can see that I've watched a lot of these, but the other thing is this repository, which utilizes a game that was designed, and this repository was written by the Primeagen as well, but essentially I'm going to try to copy this, essentially, and kind of shove OCaml in there, is the idea. But before I can do that, I need to understand better how this all works. Obviously, this is built for TypeScript versus Rust versus Golang, and that's excellent. It's because there's a lot that can be used here. However, this isn't necessarily designed for OCaml usage. So that's kind of why there's a little bit of that consideration. But hopefully, once I learn a little bit about performance profiling, I will be able to handle that kind of project. But what is performance profiling? Basically,
performance profiling is a way to measure the resource usage and other metrics of a program. This may include the CPU usage, memory usage, speed of the program, and other important metrics.
So why does it matter? So performance profiling matters as much as performance matters, right? It's kind of like, how exactly are you going to increase the performance of your application if you don't do any performance profiling? That being said, a lot of applications maybe don't require performance profiling, at least right away. That shouldn't be the primary thing that you focus on. Premature optimization is a trap, and that should be avoided. If you prematurely optimize your code to be extremely performant, well, you don't know what it means to be performant, because you don't know what your users actually care about, and you don't know how everything is going to change until your code becomes rigid. And by rigid, I don't mean that in a negative light, but I mean that in that this is not going to be changing anytime soon. Until your code becomes rigid, you shouldn't be focusing on performance as much as developer experience. When the code isn't going to be changing anymore, that's when you should focus on developer experience. So I'm going to make a new section called why doesn't it matter?
Avoid premature optimization. Don't optimize your code until you know that it won't be changing often. optimize instead for developer experience, while developers will be interacting with it often. Once your code base has become relatively rigid, that's when you can start optimizing for performance, because you know what performance to optimize for.
So, why does it matter? Well, we covered why doesn't it matter, but obviously people do care about performance. You want your user experience to be excellent. So some of the reasons why it may matter is just user experience. If the application, or if a certain button takes forever to load when maybe it shouldn't, that is something that the user might not appreciate about your application. If the app is slow and groggy, the user might be turned off by it. Now, the other thing is money. And that is possibly one of the most important aspects of a performant application. If you have an application which is slightly less performant than it could be, well, resources cost money. CPU costs money, especially in this day and age when we have the cloud running everything. It isn't just your own computer, it's the actual CPU usage and RAM used by an online computer run by another company. So resources cost money, and in order to utilize those resources most effectively, you have to run performance profiling. And everything good comes in threes, so I feel like I should come up with another reason. And I'd say the other reason is kind of just learning. And I'm sure that there are plenty of other reasons that people can come up with. If there are other reasons that you think of, definitely leave me a comment, because I would love to hear them. But for me, learning how to actually optimize the performance of a program is such a valuable experience. There are so many different performance tricks and ways to increase or decrease maybe the time complexity or memory complexity of a program, and really optimize a program that teach you very fundamental and different aspects of programming and computer science and different concepts just generally, where basically when you're performance profiling and then later on optimizing your performance, you're going to be learning a lot. So profiling
performance plus later optimization leads to acquiring knowledge.
So why does it matter? User experience, money, and learning. So then the question becomes, how do you measure performance? So in fact, instead of having this in the same file as all of these, I'm going to make a new file, and I'm going to call this how do you measuring performance. And I guess this is just like profiling performance, but I don't want to have the concept and the method in the same thing. So now that we know what performance profiling kind of is, let's take a look at how to measure it. So there are a lot of different ways that you can measure performance, and I'm guessing that in order to do it, it looks something like this. First, and this method may be completely wrong, I'm going to try to refine it over time. But I figure I should come up with my own method of doing this and then kind of go, that was a terrible way of doing it, and iteratively learn. The best way that I learn is by trying to do the thing and failing miserably, and then learning why I failed miserably, and then basically learning from that. So step one, in my opinion, is to identify the key metrics. So, for example, let's say that we had a request. For example, we have a request which takes 10 seconds to complete. So, for example, I work on an app currently where there are some pages on this app which essentially, when you go to load them, because of the nature of the application, it can take up to 10 seconds to actually load a page. And we're talking about a React app here. This isn't that's obviously like not indicative of its performance, but we're talking about like an app that people actually use, and it's taking multiple seconds, if not like 10 seconds, like to actually load a page that people will go to all the time. And that means that the user experience isn't particularly good. So essentially what I mean by identifying the key metrics is I want to know the amount of time that the request is taking, and that is because I would like to decrease the amount of time. So I guess maybe instead of step one being identifying the key metrics, maybe step one would be identifying the goals. So, for example, lowering the amount of time that a request takes, and to be a little bit more specific, lowering latency on page load. So I go to a page, I want to see the stuff that's important to me on that page, but it takes multiple seconds for it to load. So it's kind of annoying in that sense, and it does slow my workflow. It might be 10 seconds now, but if I do that 10 times, then that was 100 seconds. If I do it 6 times, then that's 60 seconds, and that's a minute. So if we're talking, the amount of saved time that I would have if clicking that button loaded a page almost instantly, then that's extremely useful on my end of things. So step one, I would say, is identifying the goal. So for example, and we'll make this a little bit, that's not bold. Get my markdown confused sometimes. But for example, lowering latency on page load. So that is the goal. I want to take this page and I want to lower its latency. So that is sort of a discrete goal, and that is like an actionable goal, I should say. So, however, there might also be an overarching goal, which is what I mentioned, sort of decreasing or increasing productive time / decreasing wasted time. So the overarching goal is probably something like increasing productive time and decreasing wasted time, whereas the actionable goal is therefore going to be lowering latency on page load. The actionable goal should perhaps be derived from the overarching goal, and the overarching goal is derived from user feedback and understanding the user's problems. So the overarching goal is derived from the users, from feedback, essentially, or something. And then the actionable goal is derived from the overarching goal. So I'm not actually going to keep this note in here because I don't think that the overarching goal should specifically come from that. The overarching goal can come from anywhere. Your goal can be whatever you want it to be whereas the actionable goal should probably be derived from the overarching goal as a solution. By the way, if you're watching me just go through these notes, and I'm probably being incredibly boring here, but if you're sticking around and just hanging out, that's kind of the goal of these videos for me. I just kind of want to create a little bit of a community, and not even that as much as just kind of chill out, write some code. Personally, it helps me to have a goal and then like record myself doing it to hold myself accountable. But if you're just kind of chilling around and hanging out, that is the goal. So thanks for doing that, and yeah. Anyway, so step 1 is identifying the goal. Overarching goal, increasing productive time and decreasing wasted time. The actionable goal derived from the overarching goal as a solution, and we might say as a potential solution because you don't know much until you try. That is what is going to actually be what we use to determine our metrics, which I do think is maybe step 2. I guess we'll see. So step 2 is identifying key metrics. So I guess you could abbreviate to this to like KPIs, key performance metrics. But since we're already talking about performance, I'm just going to say key metrics. Basically, we want to identify what we should be measuring in the first place. So, for example, in order to lower the latency on page load, we need to actually measure latency. Per hour lowering latency example, what metrics will be important to do so? So, what I would say is that it is incredibly important in order to lower latency on page load. We would like to essentially identify the key aspects of what actually makes up latency and measure those. So the first most obvious sort of how do we kind of tell if we're getting closer to our goal is to measure latency. So the key performance metric, so the key metric basically measuring our success. So the success metric, we can call it, will be if I can use notes, that is. So success metrics would be the latency measured by time, average load time. So that would be the success metric, and therefore in order to and then for the overarching goal, so perhaps we have latency as the actionable goal success metric, whereas the overarching goal would be productive time. So increase in productive time, overarching goal success measured by, and then latency would be the actionable goal success measured by. So our overarching goal is the increasing productive time and decreasing wasted time, and the actionable goal is lowering latency on page load. And so if I want to measure whether or not I'm successful in my overarching goal, I'll need to measure the increase in productive time. Now, that being said, you could also say there would be a decrease in wasted time. Now, the specific issue with this is that and why the overarching goal isn't the main metric that we should be sort of measuring in my mind is that if you increase the productive time, that isn't necessarily indicative of a lowered latency. Similarly with decreasing the wasted time, just because the time that the users spend being productive is increased doesn't technically mean that the latency is lowered, but it is fairly indicative of it. So more specifically, we need to actually measure the latency of every every page load time, and then we can sort of correlate that with the decreased waste time. Now, what we should actually clarify is how we're going to measure the decreased waste time. So the increased productive time or a decreased wasted time is going to be measured as a percentage of the total time. So the total amount of time that they end up spending on our application or using it for things that are important, the total amount of productive time that they spend is going to be measured based as a percentage of the total time that they are actually using it. And we should be more specific, the total active time. So increasing performance time, decreasing wasted time as a percentage of the total active time. And that's because if you're just kind of hovering on the app and it's open in another tab, but you're not actually using it, and so you go over to, you go over to your other tab and you're kind of playing a game and you just have the app open, that doesn't mean that you are being productive. And that doesn't mean that you are actually, actively doing stuff. So we want to know when you are trying to be productive, how often are you actually productive versus not? So essentially, the overarching goal should be decreasing non-productive time as a percentage of the total time spent trying to be productive. And then the actionable goal will be lowering latency on page load, and this can be applied to multiple pages, but we'll just go with one for now. So just as an example. So then we've kind of gone over what we actually would want to sort of measure in order to indicate success. So success indicators would perhaps be, for the overarching goal, the decrease, I just realized my typo over here, the decrease in non-productive time as a percentage of the total time spent trying to be productive. And then the actionable goal success indicator would be the latency of a page load. And I shouldn't say a page load, I should say because we're going to be measuring a specific payload. The actionable goal will be measured by the latency of the page load, measured by average load time. By the way, if it seems I'm being a little bit anal about this and really reiterating a lot of things over and over and over again, that is a little bit on purpose because I really want to kind of get this performance metric system, step-by-step process down. I want to sort of get this protocol down so that I can apply it to multiple things. So, step 2 is identifying key metrics. Per our lowering latency example, what metrics will be important to do so? So we have our success indicators. Now we need something that just kind of lets us actually understand the problem. So we want to basically build up our profile. So that's where we get into our profile metrics in my mind, where we essentially want to measure the different sort of resource usage. We want to measure things like the time it takes for the page to load. So that is just like sort of the overarching metric. But in order to actually sort of break that down, we want to measure the time for the request to be routed. So when we make a request, we basically want to trace every aspect of that request. So we want to maybe break each of these profile metrics into specific things. So the time should be, per our example, when you first make the request, your browser is making an HTTP request. Now, that probably isn't something that you can control, but perhaps it is worth taking a look at the time that it takes for your browser to actually send that request. Maybe depending on the library that you're using or some specific implementation, you have a bit of a bottleneck there. So basically, we want to trace every step of this path. Now, of this request. So identifying key metrics, we would like to, in order to identify the profile, I want to kind of keep the identifying key metrics step here, and so I don't want to get too low level quite yet. So profile metrics, we're going to do time, and then we are also going to measure, I'm trying to think of what else might affect this. It's also worth noting that you might not know all of your profile metrics right off the bat. So let me actually make a little note of that, because that seems like it could be important. Shoot, how do you, I think it's like this. Warning, you might not know all of your metrics right away. So essentially, yeah, you might not know what you're actually trying to measure until you start kind of poking around a little bit and identifying, you might identify bottlenecks and then realize that you have other things to measure. So this is kind of a loosey-goosey step, or it's like try your best, but at the same time, there's only so much that you can know before you start actually poking around. So the first profile metric is going to just kind of be time at a high level. We want to know how long this request takes, and sort of eventually every part of the request. So then I'm going to actually make a note of that. So then we have, other than the time, I'm thinking that we also want to measure sort of server resource usage. At the time that a request is being made, we want to measure the CPU usage. We want to measure the memory allocated, things like that, because those could affect, one, the amount of time that it actually takes, which is one of our success indicators, but it could also affect the just kind of, yeah, that would essentially affect the amount of time that it takes. So we'll measure the resource usage. We want to identify a baseline resource usage. And then we also want to have a resource usage at request time. And then we would basically want to measure this over the course of the day, but that's probably not something that we need to write down here. We're trying to get more of a high-level overview. So we want to measure the time as sort of part of the profile. And the reason why time is in both of the profile in both the profile and in the success indicators is because if we want to, the success indicator for the actionable goal is the latency of the page load. So that is the average load time of the page, and so the load time is going to be comprised of a bunch of smaller sort of time blocks, which a time block would be each step of the request being completed. So in order to actually profile the request being made and identify what is contributing to the latency of the page load, and we should note that the profile metrics are things that contribute to actionable goal success indicator. In order to actually measure what is most affecting the actionable goal success indicator, you need to know what block of the request is taking the most time. Now, it may be fairly obvious in your particular application. If you're using like an MVC model where you have a controller that, so you send the request, it gets routed, it goes to a controller, the controller calls a bunch of functions, it runs a whole thing. Like, you might know like, oh, it's happening in the controller, but you need to know the specific bottleneck. So profile metrics are used to sort of identify bottlenecks. And I will move this onto a separate line like I did above. So profile metrics. Let me actually make these a little smaller. So success indicators. Success indicators are used to tell whether or not optimizations are working or not. Essentially, if your indicator is improved, that means your optimization for that indicator is working. And then I want to come over here to profile metrics and basically say, also I could probably make these. Yeah, there we go. That looks a little bit better. Actually paste in what we had written over here. So profile metrics are things that contribute. Why is it being so weird? There we go. So profile metrics are things that may affect the success indicators. These will be used to identify bottlenecks in a pipeline. And when I say pipeline, I'm essentially just saying like the steps that a request in this case might go through in order to be considered complete. You know, sort of the call stack, the stack trace, or whatever you might call it. There are a lot of different ways to sort of say it, but when a request is made, just like every step of that request being completed in this particular case, it might be something different. It might be like a function call or something like that in another application, but since we are measuring latency, when I refer to pipeline, I'm saying all of the steps that it takes for a request to be completed. So in order to sort of profile in order to actually measure these profile metrics, we want to know the time, which is every part of the request pipeline. We want to know the resource usage, which is going to be both at baseline and at request time. And we'll just keep those for now. There might be more in the future, but we probably want to move on to the next step. So, what might the next step be after identifying the key metrics? Well, perhaps it is step 3. Implementing the metrics. So now that I have well, actually, it might be identifying sort of the cascade. Now, in order to make sure that I'm using that word correctly, I'm going to look up the definition. Yeah, so it's not really a cascade. I mean, possibly. I don't think that that's necessarily the right word, but sort of identifying the pipeline. Since I said that before, it kind of follows to continue using that analogy. But essentially, a pipeline will be the different steps that are completed in order to complete this request. So, for our example, a pipeline would be the different steps used to complete the request. For example, the steps might start at making our browser makes post request, and then that goes into directly the server receives post request, and when it receives it, it is going to actually pass that and route it. So we might just put that into the routes, identify that block as maybe the route. So browser makes post request, server routes the post request, controller receives the function call, or I guess like controller method is called, and then on this particular page load, and now that I'm thinking about it, this should be a GET request because we're talking about a page load latency. But when we make a GET request and then the server routes the GET request, the controller method is called, and this is where the majority of our time is going to be spent. But because all of these are taking place at different times, we would want to measure the particular latency for each of these. We want to measure the time that each of these takes before the next block is executed. So identifying blocks might be the best way to identify it. A block would be a step in the process of going from request started to request complete. Basically, a block is a way to represent a standalone chunk of the... I'm trying to think of the best way to sort of describe this, I guess, of the program, which can be independently optimized. So that might be another important aspect of this, is saying that that a block can be independently optimized, because these are things that can essentially, like, if by independently optimized, I mean, if we want to optimize the controller method, we shouldn't also have to optimize the routing method. If we want to optimize the controller method being called block, then we probably don't want to also have to optimize the server routing side of things. So I'd actually say that this part should be removed. Server routes the GET request to a controller method. The actual method call by the server is potentially something that can be optimized, but that isn't something that will be, but the routing itself may contain the call to the controller method. So unless that can be split into multiple steps, this will be a standalone block because it can be independently optimized. So browser makes the GET request, and then the server routes the GET request to the controller method. Then there's potentially things that are done within that controller method. So maybe data is queried from the database. So we're assuming sort of a server-side rendered approach here, where specific data is fetched from the database. So data is queried from the database, Then the data will be parsed into a usable format, and all that means is like the data isn't probably in the shape that it needs to be, and so we're going to parse it into the shape that it needs to be. And then once it's parsed into the shape that it needs to be, we can build the the page HTML. Basically, we can use that data. So when we're actually building the HTML, then that's going to be an important aspect of this. And then in order to actually build the page HTML and send that back, we would need to have I'm trying to think of what else might happen after the HTML is actually built. Maybe this is where we just send the HTML back. So another important aspect of this is that there might be middleware somewhere in here. So when the browser makes the GET request, the server middleware might receive that GET request before the server routes the GET request to an individual controller method. For example, you might have some permissions middleware that is going to check if they're even allowed to touch that method, and if they aren't, then it will never call that method. So browser makes a GET request, server middleware is called, server runs middleware, I should say, runs middleware. Then the server routes the GET request to a controller method. Data is queried from the database. Data is parsed into a usable format. Page HTML is built, and then HTML is sent to the browser. And then we could even say the browser renders the HTML. So there might be something in the HTML that's a little bit weird, or there could be server-side, or there could be client-side JavaScript that needs to execute. So browser renders the HTML. This could potentially be broken into other blocks, but for now, this will be one block. Now, that being said, all of these could potentially be broken into other blocks. So what I'm going to say is I'm going to leave a note here. Basically, each block should try to be identified up front. However, each one may contain multiple subblocks, and this could be recursive as well. So essentially, a block is just something that can be individually optimized. So that's probably what I'm going to identify it as. So per our example, a block would be a step in the process going from request started to request complete. I'm actually going to modify that. Basically, a block, oh my goodness, maybe. Let's see, there we go. Basically, a block is a way to represent a standalone chunk of the program which can be independently optimized. That is the most important part right there, I believe, after kind of going through this and thinking about it. Each block needs to be identifiably optimizable, and by trying to find each independently optimizable thing, you'll probably identify the most discrete blocks and steps of the program. So basically, a block is a way to represent a standalone chunk of the program which can be independently optimized and is directly related to the process being executed. So with that being said, the next step would probably be for configuring profiling. I'm not sure how exactly to word this, but basically starting the actual profiling. Now, you can start, probably take measurements is a good way to say it. Then you'd want to take the measurements. Now you can start measuring the individual parts of the you can start taking measurements, including the time taken. Now you can start taking your actual measurements. For our example, we'll want to measure the time taken to complete each block. We also want to measure. I should also clarify that a block, so like if you're, I guess never mind, that's probably contained. I had another idea of something that could be put in there, basically like if a process is dispatched as a result of your process, but it doesn't directly contribute to your indicator, then that could be something to note, but then like maybe that shouldn't be part of it, but I still think that should probably be contained under being independently optimizable, because if something's optimizable, then that probably means that it can that means in relation to, and I can clarify that, in relation to the KPIs. Now you can start taking measurements. For our example, we'll want to measure the time taken to complete each block. We'll also want to measure the amount of time, the resource usage over the course, the resource usage at each block, and that'll basically allow us to see where performance, to identify bottlenecks, take measurements, which basically now you can start taking measurements. We'll also want to measure, and then record all of these measurements for later usage. So this is basically just identifying all of the key data that you need to use, that you need to know at each individual block. So when the browser makes a GET request, we want to know the time that GET request takes to make in the first place. Maybe not to complete, but to make, because we're trying to lower the latency, so it wouldn't make too much sense to measure just like how long it took to complete it, other than as a sort of success indicator. But now we'll want to basically measure each block's time and each block's resource usage. So, or at least the resource usage correlated with each block, and then the time that it takes for each block to complete. So let me just kind of copy all these, bring them down here. Browser makes GET request. I want to measure time taken it takes to make request, to call request function and make request. Then when the server runs middleware, I'm going to actually make all of these into a list. The other one, I'm not making a list though. So when the server runs the middleware, measure time taken to complete middleware plus resource usage at that time. When the server routes the GET request to a controller method, time, so hold on. Instead of saying measure every time, I'm just going to say what should actually be measured. Time taken to complete call plus resource usage at time. And then data is queried from the database, time taken for query to execute, resource usage at time. Data is parsed into a usable format, time taken for parsing function to return plus resource usage at time page HTML is built, time taken for HTML to be built, plus resource usage at time, and then HTML sent to the browser, time taken for HTML to be sent, plus resource usage at time. You probably couldn't have guessed it. And then browser renders the HTML, time taken for HTML to be rendered. So that part, unless it's down on the server side, is just going to be a client-side thing, so we don't want to be measuring resource usage on the client side because it's not something we can control. So once we've taken our measurements, we can make observations. Step 5, make observations. So I'm thinking, because we're taking these measurements, right? The browser is going to make, so we're taking measurements. I actually want to go about this. So I'm actually going to say that this part is identify bottlenecks plus considerations, I guess. Because at this point, it's important to note that now that you have, like, basically it's the uncertainty principle, right? It's like in order to measure something, you actually do have to, like, you have to touch it, you have to poke it, which is going to increase overhead. So consider things like performance overhead, considering things like performance overhead, identify which parts of your code, which blocks take the most amount of time to complete, whichever they may be, and then, yeah, so identify bottlenecks and considerations, considering things like performance overhead, identify which blocks take the most amount of time to complete. Perhaps for this, we can say, like, the browser makes the GET request. That takes, like, I don't know, 100 milliseconds. Maybe it shouldn't even take that long to actually just make the request. It's just saying, hey, server, do this, and then starts waiting for a response, but that's not what we're measuring. Maybe the middleware takes like 300 milliseconds. The server routes the GET request to a control method. That takes, like, I don't know, 100 milliseconds. Data is queried from the database. By the way, these numbers are not accurate. That kind of probably goes without saying. Data is queried from the database. Maybe this part is like, oh man, this has taken like a long time. We're going to say that that takes like 4 seconds. Now that we have the data, though, it only takes like 2 seconds to actually parse it. To parse it, it takes 2 seconds for the page HTML to be built. And then when it's sent back to the browser, it takes like, a couple milliseconds, maybe 100 milliseconds, and then the browser renders the HTML, which takes like, what are we at right now? Because I said 10 seconds, so let's go with that total, 200, 300, right? So that's 500, 600, so we're at 600 milliseconds. So let's say the browser renders the HTML in approximately 1.5 seconds. 1.4 seconds, I think, technically, but like essentially this will add up to 10 seconds that it takes. But what are the biggest bottlenecks? Well, the biggest bottleneck is technically this part, which is just biggest. That doesn't work, does it? Do this. So, this part is the biggest bottleneck, officially. And now this is also going to be a bottleneck, and this is also going to be a bottleneck, because these are all taking multiple seconds and could be potentially optimized. But this is by far the biggest one. So this is where we're actually going to want to do the majority of the work. Identify which based on, yeah, let's just start at the next step. Step 6, optimize bottleneck. I guess like optimize bottlenecks. So I'm going to say starting with the biggest bottleneck, identify its problems and come up with an optimization solution. It's worth noting as well that this particular step has a lot of nuance to it and could definitely be an entire step-by-step process on its own. So now that we've kind of, identified our bottlenecks, we can start optimizing them, which I think will kind of look like, optimizations make the query more efficient. The query also could be affected by things like disk usage as well. So we could say like, optimizations for data query. Make the query more efficient, boost disk, I guess like disk bandwidth, I think it would be. I'm not sure if I'm using that term correctly. Optimizations for DB query, make query more efficient and boost the disk bandwidth. That might be all that you really need. And then for the other parts, we'll say other parts as well. And then we'll go into step 7. Once you have optimized your bottlenecks, then after you kind of can evaluate your key metrics again. So now that you've kind of done this, like evaluate success indicators. Basically, see if your optimizations worked at all. If they did, your success indicators should show it. If not, they won't. Fairly straightforward stuff right there. If satisfied, move on to step 8. I guess you're done. If not satisfied, move back to previous steps in order to become satisfied. So it might be as far as going back to identifying blocks, but essentially, taking the measurements and identifying bottlenecks and considerations, and then optimizing the bottlenecks. Like these are going to be 3 parts that are going to be the most important, but that should technically be it. And I think based on this, I have a lot to work with in order to start actually measuring performance. I got a little bit sidetracked as to how to measure the performance of a specific language, but I think that we can apply this step-by-step process, and at least I'm going to try to, in order to actually build up a very nice profiling solution. Maybe not a solution, but like in order to build up a profile of OCaml versus Golang specifically. And then Rust and JS could be in there as well. So anyway, if you stuck around, I'm extremely surprised. If you got bored and left, that's okay too. If you're here at the end because you wanted to see what I came up with at the end, here it is. Identifying the goal, identifying key metrics, identifying blocks, taking measurements, identifying bottlenecks and considerations, and then evaluating your success indicators. So I'll probably go over this more in the future. Like I said, I do plan on making a better sort of video in the future. That's going to be way more condensed. It's not going to be as rambly. It's going to essentially just kind of go over this at a much better level. So happy coding, everyone.